Auto exposure, or the eye adaptation effect. This effect is used to increase or to reduce the exposure on the camera lens to simulate how our eyes behave when it's exposed to light. Therefore, the camera is seeing the scene darker or brighter depending on where and how the camera is placed in the environment. AAA video game development companies uses this effect whenever the player is entering or exiting a dark or a bright area. This effect works best when there is a significant difference in luminance values. This is why we don't really need it for the scene, because luminance values are stable. Before diving into the auto exposure effect, we need to set up the camera. In Unity, unlock the inspector, then go to the main camera and go to Add Component and search for Mouse Look. Add it, then expand it. This script comes with the free environment package that we are using. It allows us to move and look inside the environment. I already added it, and I tweaked the values and found that these are the best settings to debug inside this environment. Press play and use WASD to move, and your mouse to look. Now to add the auto exposure effect, go to the post-process volume component, then add effect, then auto exposure. For its properties, the auto exposure effect uses the filtering value to determine the upper and lower percentages of the histogram to be used to find a suitable luminance. So what is the histogram? Let's select our camera and go to the post-process debug component. And as we discussed, the post-process debug component displays real-time data about post-processing effects. To debug the luminance of our scene, go under Monitors and toggle Light Meter and make sure that Show Curves is disabled. Then press play. The light meter is a graph displayed on the top left of the screen. It gives us information about the exposure of our scene. If you point the camera towards the neon light, you'll see the histogram highest value is about 1. If you look down to the floor, you'll see much darker values along the left here. So let's drag our minimum to about -2. Now you need to adjust the exposure compensation. Set it to 0.5 to average out a bit. And play with the filtering until you found a range between the two that you are happy with. You can notice the effect when we are moving inside the environment. And for the adaptation type, we have two types, progressive and fixed. And you guessed it, the progressive adaptation makes a gradual transition between dark and luminant areas. Speed up is the adaptation speed from a dark to a bright area. Speed down is the adaptation speed from a bright to a dark area. On the other hand, fixed makes an instantaneous transition. This is it for the auto exposure effect. See you in the next video.